So this is the third case where object is kept at 2f1. You can see in the figure I have kept object AB perpendicular to principal axis and the object is placed to f1, and I have considered two incident rays from the object, and these incident rays are standard rays. So let's complete the ray diagram. So if a ray traveling parallel to principal axis after refraction will pass through f2, we know this path, very familiar to us. I will extend it, okay, and a ray passing through optical center will travel undeviated, so I have to extend this path, okay. So this is a point where the rays are intersecting, so definitely this will be the position of image. So if I draw the image at this point, well, I can see that the image is exactly formed at 2f2, right? So where is the position of image? The image is formed at, come on tell me, 2f2. Is it formed due to actual intersection? So this is the incident ray, this is the refracted ray, this is the incident ray, and this is the refracted ray, and the rays are actually meeting at this point. So definitely the image formed is a real, and real image is always inverted. You can see it from the figure because the image has arrow in the downward direction, okay. Now if I talk about the height of the image, it will be same as that of the object. So remember, in this case, when the object is kept at 2f1, the image is obtained at 2f2, and the height of the image would be same as that of the object, so it will be of same size. And if I talk about the application of this case, so this case is used in an astronomical telescope where we get the inverted image. I will show you, it will just take a minute to represent. In telescope there are two lenses, remember. So if I talk about a terrestrial telescope, the rays are coming from the object, and after refraction through the objective, some image is formed, okay. And if I talk about the second lens, which is called as the eyepiece, this eyepiece is used to view the object. So the image obtained due to the eyepiece is inverted. So definitely in astronomical telescope, the image is always inverted. The final image which we see is always inverted. But if we are using this telescope to view the objects on Earth, the final image will always be inverted, and it will be very difficult for us to observe that image. So what I am doing in place, okay, what I am doing in this case, that between this lens which is called as objective and the second lens which is called as the eyepiece, I will keep a lens in such a way that that lens will be used only to invert the inverted image. Are you getting me what I am saying? So this lens, this intermediate lens, is only used to invert the inverted image. So it forms the erect image, you can see. And now using eyepiece, if you are observing the final image, so the final image we can see is erect. So this telescope where an intermediate lens is used between objective and eyepiece to invert the inverted object, in fact to make the object erect with respect to original object. So such a telescope is called as the terrestrial telescope. Terrestrial telescope, remember.